So in this video, I'll be doing AMC 10B 2021 Spring 13 and 14. 13, let n be a positive integer and d be a digit such that the value of the numeral 32d in base n equals 263 and the value of the numeral 324 in base n equals the value of the numeral 11d1 in base 6. What is n plus d? Okay, so this one's pretty straightforward algebra, which I like. You know, there's really no tricks to this one. So because, like, if we want to write this number in base n, it's going to be 3n squared plus 2n plus d, right? And that's going to equal 263. Now, if we write this in base n, it's going to be 3n squared plus 2n plus 4 equals 11d1 in base 6, which means it's going to be 6 cubed plus 6 squared plus 6d plus 1, right? Or this last one, the second equation, we could subtract 1 from both sides and just make this plus 3, right? And now notice how we can subtract the two equations from each other, right? We can subtract equation 1 minus equation 2. So that'll give us d minus 3 equals 263 minus 6 cubed is 216 minus 36 minus 60. Yeah. So, or d equals, or I guess 70 if we add the 60 to the left-hand side. 70 equals 14, right? If you add all this up plus 3, you get 14. So that means d is 2, right? So now we know d is 2. So now we just need to solve for n, but that shouldn't be too bad because we can basically just plug into that top equation, right? So we can say 3n squared plus 2n plus 2 equals 263, or 3n squared plus 2n minus 261 equals 0. Now, 261, you'll notice that 2 plus 6 plus 1 is 9, which means 261 divides by 9. And by doing a long division, you realize it's 9 times 27. So I'm going to write this as 3n squared plus 2n minus 9 times 27 equals 0. Now, notice how if you were to, 9 times 29. Yeah, 9 times 29. But notice how if you do 3 times 9 times 29, you get 27 times 29, right? And 27 and 29 are 2 apart. So I can write this as 3n squared plus 29n minus 27n minus 9 times 29 equals 0, which means I can factor it by looking at 3n squared and minus 27n. I can write that as 3n n minus 9. And then here I can have 20, and I can take out 29 and have n minus 9 equals 0. So that means my two factors are 3n plus 29 equals 0, or n minus 9 is 0. But obviously n has to be positive, so n must equal 9. So we know n is 9, we know d is 2, 9 plus 2 is equal to 11. So our answer is B, 11. Okay. So not too bad as long as you have some understanding of non-decimal bases, which again comes from number theory, right? So hopefully you guys would be studying this sort of, it's, you know, this is not usually taught as a typical part of, you know, algebra 1 or algebra 2. So hopefully you would be learning this sort of on your own, or, you know, in some sort of like after school program or something like that. Okay, number 14. 3 equally spaced parallel lines intersect a circle, creating chords of length 38, 38, 34. Now, what is the distance between two adjacent parallel lines? So notice how the two lines that are 38 have to be, let me do better than that. Notice how the two lines that have a length of 38 have to be equally spaced from the center of the circle, right? In order for them to be parallel and have the same length, they need to be equally spaced from the center, right? The reason for that is because you know that a radius is always perpendicular to a chord and bisects it, so we know these would be equal. We know, and then we know this is 90 degrees, 90 degrees, and we know these are both radius of the same circle, so therefore this must equal this, right? So that's sort of a quick little proof of why that must be true. And then we have the chord of length 34 over here, so this is 34, 38, and then this one's also 38, right? So let's say that we draw like, you know, these little lines here and say that this distance is k, right? But remember, they're all equally spaced, which means from here to here must be k over 2 because, right, the whole thing would be k. So just that half part would be k over 2, right? Now, if I were to draw to here, right, this would be the radius r, and this distance would have to be 19 because, like I said, a chord, when a chord is perpendicular to a radius, it always cuts the chord in half, right? That's like one of the theorems of circle geometry. So then by that same reasoning, if I were to draw this line, this would also be r, and this would be 17, right? So now what I can do is I can set up two Pythagorean theorems, right? One with this right triangle here, right? Which would be what? K over 2 squared plus 19 squared equals r squared, right? And then one with this right triangle over here, which would be 3k over 2. Whoops. 3k over 2 squared plus 17 squared equals r squared. Or we can set them equal to each other. So k squared over 4 plus 361, right? 361 is equal to 9k squared over 4 plus 289. And then we can reduce that to become 8. So we'd have 8k squared over 4 is equal to 72, which 2k squared equals 72 means k squared is 36, means k is 6. And the question asks for the distance between adjacent lines, which is k. So our answer is B6, right? So that one's really, I thought, not that bad at all. You know, just sort of testing your knowledge of circle geometry. But overall, pretty straightforward. So, okay, in my next video, I will do 15 and 16. And I hope to see you there. All right, see you later.